In this example, we want to calculate the 95% confidence interval for some count data. So a typical example would be the number of colonies, of bacterial colonies on a single agar plate. And we make this one observation that we've got 68 colonies on this one plate. And we want to really know how many colonies should we expect on a single plate if we repeated this experiment lots and lots of time. And we assume that in this case the conditions of a Poisson distribution are met. So how can we do that? Well, we can use two equations here, and I'm in Excel. These are the equations for Excel, so we can calculate the lower bound and the upper bound. And all we need to know really in these equations is the alpha, the significance level, and the observed value. And the observed value, this is our 68 bacterial colonies. What is the alpha value? That's the significance level. We can always calculate an alpha value just simply using this equation here, 1 minus the confidence interval. So in this case it would be 1 minus 0.95, and our significance level alpha would be 0.05. So that would be the type 1 error that we are willing to make. So let's calculate the lower bound for this confidence interval. So equals chi square. And as we type, you see Excel comes up with some suggestions. And we want this one, this equation here, chi square inf dot right tailed. And now we need to calculate the first argument, the 1 minus alpha half. That's 1 minus 0.05 divided by 2. So that's this first part. And then we need to calculate 2 times 68. So that is the second part. And we need to divide this by 2 because it is a two-tailed test. And hopefully, if we closed all the brackets and entered everything correctly, then we should get our lower bound for these cell counts. Now we can also calculate the upper bound. The equation is slightly different here. It differs in these two arguments. Equals chi square inf right tail. So that is this one. Now we need to calculate alpha half. So that is 0.05 divided by 2. And we want to have 2 times observed value plus 1. So 2 times the observed value, that was 68, plus 1 in brackets. We need to close that bracket here. So looks like we've closed all the brackets, divided by 2, and we should get now the upper bound for the confidence interval, and we've got 52 and 86 colonies for the bound for the confidence interval. So the true number of colonies on a single plate in this experiment, if we repeated this experiment a lot of times, we would expect roughly between 53 and 86 colonies per experiment. We can also do this in an online calculator. And here is the link to this online calculator where we are working with count data. So here we've got a sample and we've got 68 colonies. Here it says days, but we just simply say on one plate. And again, we get 52.8 to 86.2 colonies That would give us our confidence interval, and that is pretty much in line with what we just calculated here. So I hope this makes sense, and thank you very much for watching.